let's start. There are a couple of announcements. We've discovered that Ubuntu shell doesn't do everything that we need it to do. So we recommended installing Ubuntu on a USB stick and using it on your laptops. How many of you did that? Is it working fine? For those of you who didn't do it, you can try doing it. And the alternative is use VirtualBox. So there are a couple of people who did that already as well, and they said the laptops had some issues when booting from a USB. So if you observe some kind of difficulties, you can alternatively use VirtualBox and install Ubuntu on the VirtualBox directly, and that seems to work fine for now. Yeah. Yeah, exactly. So the course is a little bit fast-paced. So every week we expect you to get to kind of the milestone. And if you don't do that, then you will be falling behind and it'll be harder for you to catch up later. So I strongly encourage you to install either the USB Ubuntu installation or the VirtualBox after this lecture. So let's say for tomorrow or for the remaining of this week, you will be able to play with the material that Chris will be presenting today. So that's one thing. The second thing is we have a mixture of third years and second years doing this course. So those of you who already know Linux and who already know command line and have been through some of the operating system courses and so on, some of the material Chris will be talking today, you already know it, so that's okay. We have to go over the material because the second years didn't have it, right? So some of you, if you already know something, you know, just learn something new, okay? Yeah?
Is this entire lecture going to be basic Ubuntu or?
Well, it's mostly basic shell. That's the key thing. So we are fairly agnostic about the distribution that's set in the computing area. We will mostly be dealing with Ubuntu anyway, because most of the main cloud providers like AWS, Azure have their base images based on Ubuntu. So it's probably worthwhile to deal with this. Only simplification that we introduced for you guys, since you're probably more developing than just running, we're using Ubuntu desktop here. Generally for running, you would only use Ubuntu server. But you probably appreciate some GUI features and the ability to install IDEs and stuff. So that's why I went with the desktop variant. But apart from the GUI, everything should be the same between the server and the desktop version of Ubuntu. So to answer your question, we try to be as agnostic as possible. And I'll point out the places or the situations in which
are Ubuntu specific.
Distributions differ. So we'll highlight this. But feel free to ask that if you are unsure, you know, if I'm confusing the boundaries there. Yeah?
So part of the lecture is kind of comparing the distributions and so on. But as Chris said, most of the stuff is like Bash and Shell, and it's distribution agnostic. So any Linux will work pretty much the same, with some exceptions, which Chris will highlight. So that's the second thing. And then the third thing is we have a Blackboard channel. I set up like 2 discussion forums, but you know, it's up to us, up to you guys, what you want to have. So we would like you asking us questions or asking other students questions. So if you have suggestions of how to structure the questions and answers or how to organize the Blackboard workflow, please, you know, comment on it, right? So if you want some forum, like we were thinking of adding, for example, a forum for programming in Go specifically. If you think it's a good idea, we may add it in. So all the discussions and questions related directly to Go may go under one banner, right? It will be easier to organize discussions and so on. So if you have any suggestions or any ideas, just post them. There is like a generic one, so post it there and use it. So we've noticed in previous years that it actually helps discuss topics and, you know, get better understanding of some of the more difficult topics. And also we get to know what you don't know yet, right? What we have to focus on. So please use those forums and questions. And I think I marked both of them, or at least one, the generic one, that you can be anonymous. So if you're kind of not sure if a question is stupid or whatever, you can ask it anonymously as well, right? So no pressure. Those were the 3 main things.
I think also Blackboard is a good starting point. So all resources will be linked from there. So the YouTube channel, which we are streaming to, as well as the course descriptor, all the lectures and so on. So even though we may write them on the board or paste them somewhere, they will all be contained in Blackboard as well. So it's your go-to place if you're unsure what's happening in cloud computing. So.
Yeah, so to give you a little bit of a context, last week we spent on to mucking around with the infrastructure, with the setup. It kind of, overfilled a little bit towards this week. You still need to do a little bit of a setup this week, but we're focusing on shell, on basic command line tools and kind of remote access and so on. So Chris will kind of go on with the introduction, and then there will be some practical sessions today and tomorrow. Next week we will dive into Go and to programming with Go, and we will do some server-side programming, and we will not dive deeply into networking, which we'll do the following week, right? So the plan for the next 3 weeks is kind of like that. All right, so I will leave it to Chris.
Thanks, Marsh. So we feel we need to build a basis, right, for you guys to understand what's happening. So those are the 3 core components: Linux, networking, Go. So we have a programming language, we have an operating system we're running things on. Well, and surprise, surprise, we need some networking to understand the cloud. So looking at the challenging bit of setting up Linux in the first place, as we did last week, it's probably worthwhile to go a bit more in-depth into the Linux concept to get everybody acquainted with the system. How many of you, again, we asked the question actually last time, but just to give me an intuition, firstly, how many of you have a solid background in Linux? 2, 3, 4, cool. Sweet. How many of you are actually running Linux right now in whatever fashion? Cool, that's a bit more. It's nearly half, I guess. Yeah, so 1/3 to half, roughly. So that's fairly good. But I'll really go over the motivation behind Linux to get you a better understanding, and hopefully after that you have a bit more of an insight how to work with Linux, but also feel comfortable using it. The important thing is really to spend this week really setting it up and getting comfortable with the navigation at least. So next week we can be fully productive and not, wonder about basic or simple navigation commands and principles. So I will also need to preempt you here. This lecture will be a bit full of material, so it's a bit, heavy load on theory. Whereas in the future we obviously shift more towards practice. So my apologies in advance, but it's unfortunately necessary as part of this. But we start off with a perhaps insightful question. Does any one of you know that guy? Yes, right. So you guys know that picture, or is it totally new? So I was in his what was it? End 80s, early 90s days of studying at the University of Helsinki, right? So that's where he was originally based, and he was basically the co-inventor, or basically developed the core of Linux in the first place. Nowadays, he's not the most dominant contributor anymore, but he laid the foundation and still guards the entire principle. In fact, if you see him nowadays, you see him more like that. That's more conventional. Does anyone know what happened there? Yeah?
I think he was mad at the media.
Yes, yeah. Exactly. More context? You know why?
They don't want to help make the graphic cards drivers supported on Linux.
Exactly, right? So Linux traditionally struggles with getting some traction on the gaming market, right? There's SteamOS and various distributions that try it, set-top boxes, but they never make it. And the reason is really that the GPU developers like NVIDIA and AMD are not really producing high-quality drivers for Linux. So you end up with some sort of open source solutions which are not optimized, but kind of work generically across the entire range of models that they have. And he was opposing that and was suggesting that they would invest more time and energy actually customizing graphics drivers for the Linux platform. So it's his way of motivating. I hope we take another approach in that course here, so a bit more inclusive. And this was his first email. So basically, the way he introduced Linux was basically on a mailing list. And as part of his courses in at the University of Helsinki, they were using the operating system Minix, which was very hot at that time to actually get into operating systems, understand them, building elements of, file systems and scheduling and so on from scratch. And Minix was the system to use at that time. Everything else was hardly affordable, well, Windows was not particularly attractive anyway, since that was in, well, 1991. So which version of Windows did we have there? Windows 3.0 perhaps. But anyway, it wasn't an option because they were serious developers and they wanted to work on Unix platforms, because Unix was the platform to work on, was used on mainframes and so on. And Linux basically rewrote a Unix version, or Unix seemingly compatible version, for 386 Intel 386 processors, and exploited all the intricacies that those had to offer. And it was the first time that you could actually run a fully fledged Unix on consumer hardware. Yeah, because as a student, you know, you don't have the most, or at least didn't have the most flashy systems at that time, and certainly not some sort of mainframe architecture that you could, you know, deploy a Unix on and then link to it and so on. So the idea was literally having a simple 386 variant of Unix, or Minix compatible, and basically make it available. But he didn't really have the hope that it would be picked up beyond Minix fans or beyond the institutional or academic environment. Today we know it's probably, the story has played out quite differently. But this was the basic starting points. And we know nowadays that it pretty much runs on any platform you can consider. Looking back, I mean, I mentioned Unix just before, and this is basically a foundation. The idea that the developers would need to be acquainted with a contemporary, at that time, contemporary operating system that would run in most industrial environments. And that was basically Unix derived. So Unix itself was developed in 1969 onwards, coinciding with which programming language? Which programming language was developed at a similar time? Yes, C, right? So it was the key feature to actually early introduce C into Unix and use it as a mainstream programming language, which kind of was semi-portable-ish, as opposed to having highly specialized solutions. And then there were various editions and variants of Unix before it actually split off into a more, what is considered a more commercial branch on the left side, so System 5 system. So they're all building on the 5th edition of the original Unix, and a BSD branch, which was driven by the idea to be as dogmatic about the Unix principles as possible, yet cutting ties with all the restrictive licensing attached to it, because it was developed commercially. Particularly AT&T was the key driver in its development, and the idea was to actually make it accessible, you know, without any cost, at no cost. And that was the BSD, the Berkeley Systems Distribution, developed at the University of California in Berkeley, right, Nayosh? Right, roughly there. And the rest was basically spin-offs from dominant, you know, players at that time. And you probably still recognize some of them, like Sun, for example. They initially started out with under the BSD license, but they quickly converted into the more restrictive commercial branch. So we see Sun Solaris. So Solaris falls under the System 5 variants of Unix. And AIX is still used, particularly in supercomputing areas. IRIX, SGI, Silicon Graphics in International, I forgot. So basically a graphics chip producer, in particular HP and so on. And the most relevant players in this market are probably still SEO, because they constantly sue or try to extort license fees from Linux users. But other than that, there's not much visibility in this range. So basically the idea was we had those two conflicting branches. Ones that were very dogmatic about the traditional use of Unix command line and Unix principles, and then this commercialized branch. And nothing of that was basically either accessible from a computational viewpoint, meaning Linux didn't have the hardware, or wouldn't be able to pay license fees. So the only option was to rewrite everything from scratch, so without any ties to any licensing, and for hardware that he had access to. Yeah, and that's why he created Linux in 1991. That was the key idea. In 1992, he made it fully open source. So that was basically the starting point for its success, picking up at that time. Something that coincides with Linux. You can't mention Linux without mentioning the GNU initiative. And you probably have seen that before. Who's comfortable with GNU software? No? No one? Yeah? Cool. Which did you use any particular software package or library?
tools covering
Okay, okay. So
some of the tools.
yes, okay. So can you elaborate on the GNU initiative or the idea behind it?
Well, it's supposed to be free, and you're supposed to be allowed to participate and
Yes.
in developing it, and you're also allowed to use tools from it in your own tools as long as you tell people that this is not my code, this is new, and this is this version of something.
So the GNU initiative is probably the strongest propagator of copyleft licensing. Basically, the idea is really every piece of code that's written can be freely used, but more importantly, reused in your code. But you're obliged to publish your code on the same license generally. Yeah. So that's the GPL license, famously here. It means that every code developed under this license scheme will remain open forever and will be reusable. So. I think it was Microsoft that described the GNU initiative as a kind of cancer, because as soon as you have open source software in your environment, you will always need to publish your subsequent developments, which would challenge the idea of having some sort of private property over your software or private intellectual property. The key person behind this whole initiative is Richard Stallman, a researcher turned I would say activist at least. So he is quite particular about the use of open software and making things openly available. Was the creator of Emacs. What is Emacs? Anyone? Yep.
Really feature-rich text editor
Mm-hmm.
that has pretty much everything built in. Like you probably can get a web browser, it has a packaging system.
Yes.
Everything you can imagine, even Evernote plugins, Spotify plugins you can get for it. Extensive.
Can I assume you're using it?
Yes.
Okay.
You can download Spacemacs. It's a really good distribution of Emacs. Makes it really user friendly. Gives you all the packages you need to cover.
Cool. Well, that's one of the possible options. So a very rich editor, basically, but very important in development scene still. So probably to stay there a long time. So what was the issue? The GNU initiative, anyone else? No. The GNU initiative was active since 1984, so mid-80s. They had heaps of those software packages, but they didn't, and they were all built against the general Unix kernels. Issue is, well, you still need to get some sort of high-performing or costly license to actually run your free tools, which is not particularly helpful. So they wanted to have the kernel, the core of the operating system, to come along with those utilities. So we have a fully fledged operating system that has both the kernel that's open source as well as the software that has been contributed individually by selected set of contributors. And this kernel was indeed in the making. It's called GNU Herd. And but even now, it's only in version 0.9. It hasn't really made significant progress, and the reason is simply that the uptake is very limited. But also its nature of its architecture. It uses, they haven't heard operating systems, right? No. It uses a so-called microkernel architecture, where you basically plug in all operating system functionality, service functionality, as modules, basically. And this basically slows down the development considerably, whereas Linux is actually monolithic kernel. So everything has been conceptualized from the get-go and is included in the kernel. But this is still active. There's actually a Debian distribution that runs GNU Herd as its core kernel. Yeah? I'm not going further into that one, but what happened was Linux was basically put under GPL in 1992, and they quickly adopted Linux as the default kernel for the GNU environment. So if you read GNU Linux, it means Linux plus the GNU software collection that's available. And that brings us to the differentiation between Linux, GNU Linux, and what is referred to as a distribution, right? So I'm trying to highlight here the differences when we talk about Linux. It's always important what kind of terminology you're applying in a particular context. And by default, Linux only refers to the very kernel, right? Only to the elements that control your computer hardware in the widest sense and interact with the user to some extent. So it includes the addressing of hard drive, input-output devices, all that kind of stuff, scheduling processes. So actually, if you have multiple processes running, it allocates processor time, memory management, and so on. all those different aspects. But it is actually really reasonably bare bone when it comes to interaction with the user. It has a system call interface, which is used by your programming languages to some extent, but actually the user tools that you will be dealing with, and some of you dealt with, like CD, PWD, we talked about some of them, LS, for example, they are actually all part of the GNU collections. Yeah, so they're actually the GNU core utils. They're sitting there. They're technically not part of the kernel itself, but they interact with the kernel. Yeah, so they have been written to be able to access Linux kernel functionality. So the very kernel is not something you would directly interact with, but we're actually only interacting with the system utilities or higher level applications that sit on top of it. And so what would be considered a coherent operating system would be a combination of those utilities and the actual kernel. Now, you guys know that Linux comes in different flavors, right? So, and they generally refer to as distributions. And the key difference is there that this software, which is put, or added to that distribution, distributed with that distribution, there you go, is very specific to the use case of a particular distribution. That's why I signified it this way. And those distributions concentrate either on security, stabilities and other aspects. They could be recovery systems, multimedia support, or fancy UIs and so on. So there's an abundance of those different distributions. Can you guys name a few ones? Yep. Sorry?
Manjaro.
Yep. Manjaro.
Linux.
Yes, cool.
Fedora.
Fedora.
Mint, all of the two flavors.
Yep, cool.
Debian, something like that.
Debian, yep.
SteamOS.
SteamOS, yep, cool. What's SteamOS used for? I mentioned before.
It was an attempt to bring the Steam big picture to Linux.
Right, so gaming,
Like,
right?
be independent from Windows.
Right. So it was basically, to be right, to have more portability between games, between two different worlds. Did it work out?
Well, it kind of, I think, even if people don't use it, it has sort of an effect that it forces Windows to be more corporate, to like cooperate more with Steam. Like,
Okay.
They know if they don't cooperate, they will have an alternative. But
Right. But
that's just speculation.
yeah. I understand the struggle is still that the game developers actually don't want to customize their games for Linux. That's the predominant challenge in Steam, and simply not much of a user base right now. But it's a very good point.
We have Kali and
Yep.
also, if I'm not mistaken, also
Android? Yep. Cool. So we all know Android, right? So what is Kali used for?
That's a lot like hacking tools for testing security.
Right. Yeah. So security suites. Yep.
Raspberry OS.
Yeah. Raspberry OS. What's that based on? Yeah. Which one? I think it's based on Debian, if I'm not mistaken. Anyone else?
There's several. So
Okay.
Archbase and Debian.
Right. The
But
Archbase.
largest one, like the default one is Raspberry.
Right.
That's Debian.
Yes. Right. Okay. Cool. Any other inside ideas, distributions? Well, the point is you can't even list them all. You see right now, right? In those 2 minutes, people came up with different distributions, quite a number of them. But I just want to bring up a bit more of a comprehensive overview of the distributions that are kind of available and their main family trees. So this is the Linux distribution timeline that's regularly updated and has been led since 1992. And you see how it kind of branches out. And that's actually a zoomed version already. Hang on, let me zoom out a bit to give you a bit more of an appreciation. So that thing goes actually down quite a bit. So and I'll discuss the major branches, just to give you an appreciation. Nothing you want to learn by heart. We may ask in the exam, though, but we'll see about that. So I probably don't make it. But what you see, notice that you have 3 different branches. So this one is the Debian-based branch over here. Right, so everything deriving from Debian, and you see it's quite a bit here, and you see that cluster here, branching out from here. This is Ubuntu, right? So Ubuntu has made a significant dent into the market share of Linuxes, and it came up in 2004, I believe. I'm not sure if you guys were subject to all those free CDs that were, or DVDs. Were DVDs? Yeah, must be. Yeah, were DVDs sent out at that time? No.
Yes.
At that time, if you wanted to, you just sign up and they send you DVD, because it was still reasonably prohibitive in some cases to actually download their images, right? So I think that made a huge impact in the uptake. Plus, they had a really well-working Linux, whereas the other ones required a lot more configuration in that respect. So that's Debian. So Debian is kind of really rich in terms of descendants. Then there's the other one, is the Slackware. That's a bit more of a hacker Linux, I guess. Has anyone come across that thing?
I use
Yeah, you?
no,
No, okay. Marsh?
I used it in the early days. It was just TGZ packaging, and you did everything manually.
So it's very, very barebone, extremely barebone. That was one of the key features. So it's really kind of narrow in its terms of the sentence, but it's still very important and existing and often used. In fact, SUSE Linux, which you may know, derives from Slackware originally, but I think they're branched over using in the Red Hat package management system. So, and obviously there's Red Hat. Red Hat was kind of considered the first player in the market, but they were the ones that actually made, started to make consulting open source consulting a business concept in the widest sense for Linux in particular. So, on that, some of you mentioned Fedora, and that's precisely you mentioned Fedora, right? Anyway, someone mentioned Fedora before? No? Does anyone know Fedora Linux? Yeah. What's the specific intent or purpose of Fedora? So the Red Hat Linuxes were generally used in enterprise. Red Hat Enterprise Linux is the default flavor, and this is supported. You get support contracts and so on. And Fedora is pretty much the freely available kind of experimental version, if you like. They introduced the latest features that are available quite early and have frequent releases every 6 months. So if you want to have bleeding edge Linux features and software, then Fedora is your tool of choice. But the Red Hat Enterprise Linux is much more conservative, and that's fairly similar to Ubuntu and Debian. So where Ubuntu actually is reasonably modern in terms of its feature set, Debian is incredibly conservative with packages dating years back, 3 to 5 years back, in a more stable version of Debian. In fact, it's hardly useful in any context because the versions are so outdated, right? So what's your conception there? It's an interesting place. So meaning there's no point really coherently suggesting that anyone could list all the possible distributions, but that's the best guess one could actually do. So, and it really depends on your focus, what you're interested in. If you want to have tech previews, you have rolling releases, something that Microsoft only discovered recently in Windows 10. So the idea that we don't have distinct versions anymore, but continuously deliver updates, that's something Arch Linux does quite well. Stable systems, user-centered systems, Ubuntu and Mint are in this category. And then, as Marius mentioned, the Slackware is strongly modular. You really build your own operating system semi from scratch. Yep.
Arch Linux, where does that lie? Besides Slackware.
Yep. So let's see again. I checked that earlier. I think it has this thing on. It's a bit sensitive, my thing, yeah.
Maybe you can search the picture.
That is the SVG. That could work. Arch is an own branch, independent branch. So it's totally independent down here. So that was, what is that? Which year is that in? Oh, it must be 2003 or something like that. So it doesn't really branch from any of the existing big ones. But it has its own little
it uses rolling updates.
Yeah, it's a rolling update.
Yes.
Yeah.
Yes, so that's its main unique feature. But it's a highly customized Linux, meaning if you set up your Arch Linux, it's very unlikely that anyone else runs the same thing. Yeah. Whereas if you use Ubuntu or Debian, it's very likely that someone else has a very, very similar configuration. Yeah. Cool. So there's all different possible variants. Again, DistroWatch is a good thing to look at. One thing I would like to highlight is the idea of LTS variants. So more and more Linuxes come with LTS variants. That's long-term support. And that's, for example, the one we're using here as well. We're using 1604 LTS as opposed to 1704 Ubuntu. And the reason is simply that there will be guaranteed support for the upcoming 5 years for the packages. And that's quite important. Makes a difference from the bleeding edge releases that will only be supported for maximum a year, but it really depends on what's Canonical's policy again? 6 months, 12 months, I think, right? Something like that.
Yeah, 6 and 12. I think.
So that's not really long. If you're thinking about deploying your application and you only have 12 months max support, that's not really useful, right? So you want to run something reliably over years. So the LTS version is generally recommended if you want to deploy something. For development, you can go either way. But on the other hand, it makes limited sense to develop something on a bleeding edge version and then trying to deploy it on LTS version, because that most likely will go sideways. It's just something to bear in mind. Really depends on your user market. The most common differentiation of Linux is generally done by the packaging formats. So we have Debian with its apt advanced packaging tool, where they have the Red Hat package format RPM, Slack package, particular to Slackware approaches, and Pacman used by Arch Linux. So this is probably the most general differentiation that you can do. So the tools that are available to manage your software on those systems, those are not standardized. Those are not, those won't work across all Linuxes. They're particular to particular families of Linux systems. Okay, enough high-level talk. We need to get a bit lower, I guess. So if you want to interact with Unix systems or Linux systems for that matter, you generally need to use some sort of shell, right? Command line interface, CLI. Which ones do you know from your Windows life? Or which shells do you know across the board? Whether or not Windows, I'm indifferent. Yep.
I want to practice Windows.
Okay, yep.
And we have set shell and bash.
All right. Cool. So you have those two ones. Yep. Anything else? Is there another one Windows we could mention?
PowerShell.
Ah, there you go. PowerShell, right? So at least 2 on Windows. Okay. And now you have come up with 2 on Linux as well. Z-shell, bash.
That's like the two main ones. I know.
Okay. Anyone else? So unlike Windows in Linux or Unix, there's an abundance of shells. It's partially due to the open source nature or the branching of the different Unix variants that everyone has come up with an own shell with unique features and so on. And this is again a family tree that's not inherently complete. The latter part is kind of missing. There are some new shells coming up as well. Like one of the more later ones is Fish, for example. It's a highly interactive shell.
Nice Fish.
Quite nice to use. There you go. Has color coding.
Is MS-DOS shell?
That's basically a command line, from Windows. Because if you, I think if you type var, it will show you which version it actually is, and that's pretty much equivalent to the command in MS-DOS. It would just highlight the operating system version you're running, but the commands are fundamentally the same, exchangeable. Yeah. So I wouldn't consider it a different shell. Yeah, it's just the shell of a corresponding version of Windows or MS-DOS. So there's quite a bit of shells available. But you mentioned Bash. Bash is a quite important one. Why is it quite important?
I mean, every Debian variant basically is so. Right. And update and all that's Bash stuff.
Mm-hmm.
Yeah, I mean that's the one that most people use.
So by default, you're right. By default, most distributions come with Bash installed.
Arch come with
that shell. Okay, cool. Yeah. So there are variants, but Bash is probably the most commonly used, and that's the one we are probably using here in this course as well, or we will, because it's used in Debian and Ubuntu, therefore, and it has the convenience of on the one hand backwards compatibility to some extent, but also feature set which is reasonably rich from a server-side programming perspective. But part of the reason why it's so reasonably backward compatible is that it actually only has one node between the original Thomson shell and the contemporary Bash shell as we know it. So it's fairly backwards compatible, whereas the other ones have branched out quite a bit and introduced considerable changes into the original shell. So we're using Bash, which is the born-again shell, the default. in most Linuxes. Unlike Windows, you can use different shells with the same user, right? So you can have, or you could different shells with different users, or you could use different shells with the same user. And best of all, you can log in multiple times in the first place. So you're not constrained like in Windows, being logged in once, but you actually can switch between different shells. I'll just show you that in the virtual machine. Here's the Ubuntu virtual machine that I'm running using VirtualBox right now, because I can't really boot from USB on my university laptop, therefore I'm tied to the VirtualBox here. But basically, you have multiple environments, and you can use Alt F1 to 6 to actually switch between them. You notice that it changes slightly. It says TTI 1, 2, 3, 4, 5, 6. So it's different devices, different terminals that connect to the shell, and you can log in the same user multiple times or different users. Next time I should get the password right, see how that goes. So that's a bit better. And so you can figure out who's actually logged in here. Probably we come back to that later. And same story here. It's me as a user being logged in, and I can play that game multiple times. I think by default we have 6 terminals activated, but you obviously can use further variants that will allow more. But it's quite convenient, because you can do, for a developer point of view, you can look, for example, at content in your home folder, where at the same time navigate the file system hierarchy, and review details, or look into the documentation in particular. Let's say if you want to check the manual at the same time, switch back to actually do your coding. It's quite convenient. We'll come back to that in a second. I just want to show you how far the shells are different. Furthermore, you can have nested shells. So you can start a shell within a shell. Sorry? No? Okay. You can start a shell within a shell, which basically allows you to switch between shells, but also assume different user identities. So conceptually, it looks like this. We have terminals connecting to different shells that actually interact with the kernel. Why do we have this architecture? Can anyone guess why we have this kind of architecture? Unlike Windows. Yep.
It's probably from the Unix days, yes, when you have shared big computers.
Exactly. Yeah. That's precisely right. So what was mentioned here is it's basically heritage from the Unix days, with one mainframe and different terminals connecting to the actual kernel, interacting with this. And this pattern is still remaining even on a single user machine. So you still have the same feature set, which is really, really nice. I think Microsoft only discovered the idea of terminal servers in the end 90s. So it's quite a bit later. So then nearly 30 years later, then it was built into the Unix kernel already. So, but it's good to know that you have this capability. Looking at the prompt in general, you played around with last time, but I want to make it explicit so you actually know what you're dealing with. On the far left is the username, followed by the host you're working on. So you can identify which host you're working on. And then you have this cryptic set here of, in this case, tilde and the percentage sign. The tilde corresponds to the directory you're currently in. Does anyone know which directory this prompt is in right now? Laura? Yep. It's the home directory. Yeah? Tilde is a variable or a placeholder for the home directory, right? Corresponds to every particular user. And then there's the $sign. It's kind of a termination of the prompt. So, and basically after that, you can enter your command. But it indicates that you are a regular user. So if you see something like a hash there, this would be put you into super user mode, which gives you more privilege. We get to that in a second. So basically, that's the structure, and then you can run your commands there. Commands follow the rough syntax. We have a command, options, and then arguments that are particular to the command. An example is the command ls. I'll just run it in a shell, so give you a bit more an intuition of what's happening here. Can anyone read, or everyone read the stuff I'm doing? Yeah. No, it's too small. There you go. So I'm typing ls and showing the content of the current directory I'm in. Let's see if I get that bigger. I frankly doubt it, but because I'm already at 200%. Oh, no, I can do that. That would be ugly. No, it doesn't react to that. Hang on, I'll scroll to the end and we get somewhere here.
could use the Windows zoom function.
Yeah, yeah, I could use the magnifier. Yes, why not? Exactly, use the Windows magnifier.
Right?
Good point.
Isn't it better now?
It's pretty readable.
It's readable? Okay, then I'll leave it this way. Okay, cool. So CD is change directory. If I type tilde, I basically go home, back to my home directory. Hang on. Tilde, join me. I screwed too much around with my keyboard settings. So between Norse and English, that I'm totally lost now. Ah, there you go. Now it's English again. Cool. CD tilde brings me back to a home directory. I can basically browse all the content. So now I have ls, the command ls. If I want to figure out what this command can actually do, it's always worthwhile to consult the, at least that's my go-to, is initially the help, because it is kind of a concise overview of the functionality and all the parameters that you can provide. ls by default just shows the content of your current directory and only shows non-hidden files, right? So that's the key idea here. But you can go as far as to say, I actually want to see a bit more. Let's do ls with a, so that was ls without any particular parameter. Let's do ls with -a. Hang on. There you go. It shows me all files, and notice those files here with the leading full stop there. So what are those files in Linux? Those are hidden files, right? So you won't see them with a normal ls. So if you're modifying hidden files, ensure that you actually show all files. You want to get an overview first. And then there's various other parameters. For example, the long format, which I personally run most of the time. It gives you a much more comprehensive overview of the files, including the permission set, the modification date, and their size as well. Yeah. Yep.
I think LL also was the same.
LL, yep. But LL, I think it's an alias, right?
Yeah. No.
So right now, if you want to see aliases built into your particular console, and Ubuntu has quite a bunch of them, David, as well. You notice at the bottom there are 4 lines that indicate, a few lines that indicate aliases, and those are basically variants of the ls command that you can, specify. And that's the way of for you kind of customizing your work environment. That's something I encourage you to do. If you want to do this, by convention, you create a file called .bash_aliases. Again, there you go, aliases. And basically then basically modify that file and enter some alias statement. There's one in there already. Alias, and you must follow that syntax. List, for example, equals, hang on. Yes, I'm typing blind here because my keyword is in the wrong layout mode. Should have fixed that before. Well, it's not happening right now.
It's a good opportunity to show locale.
Yeah, that's a good opportunity, you're right. Or a good opportunity to change my local keyword here. So
To forward.
no, not to draw. We're not doing that here. Anyway, so get out of here, please. Cool. We get to that tomorrow again anyway, when we do a bit of bash scripting. Cool. So it didn't quite work the way I wanted, but anyway. So again, --help by convention shows the help output for a particular command. Note that it's up to the developer of that tool to specify the help output there. So it's attached to the very tool you're running. You as a developer may not adhere to those conventions and may not implement --help. So it's a bit more specific to the actual tool you're dealing with. One command, however, which is built into the system and more generic, is the man command. And manual, man stands for manual, basically. And you basically can do the same and just say man manual ls, and it gives you a comprehensive, coherent output or description and documentation of the command you're interested in, right? In this case, you find much more output, including a synopsis in the beginning, and all possible parameter sets with a bit more of a detailed description. That can be fairly long, in fact. Note also that manual is actually a program in itself, so you're actually entering it, and to get out of it, you need to press Q, whereas the help output is non-interactive. It basically returns you to the prompt immediately. Yeah. So here you can navigate with cursor files if you like. Something else we need to know about manuals, and the best way to figure it out is that it has different sections. So I just typed man, and no, it doesn't mean that the Linux kernel will blow up. It basically shows a manual for the manual. And the important thing is that we have the concept of sections in there. Every command will be allocated to a particular section that it corresponds to or that it's applicable to. And those may vary. This includes executables, system calls, library calls, special files. There's a section for games, which I never touched in my life, and system administration and kernel routines. So the reason is why the reason for those different sections is that it depends on the perspective you're working from, which section is interesting for you. For example, various commands exist in multiple variants. Let's try. For example, if we're interested in the ls command, we can, for example, suggest, well, we want to see it from the general utilities point of view. And if we go all the way up, I need to. You notice there that you have SLS parentheses 1, and that indicates that it's from the first section. So basically, you have the full functionality here. You can also test whether there is, for example, library functionality that corresponds to ls. Is there anything that you could do from a library perspective, or perhaps a system call to access ls? And this is not the case, meaning it's just the user command tool, nothing like but this. Another example perhaps is Git. You guys know Git, right? Yeah. Yep, cool. Everyone should know Git here, right? Is it, you learned that in the first year? Yeah. Cool, good. So if you run man1 git, for example, what you expect to get is basically a brief output of the command line client syntax, right? Come on. Description. So there you go. So you get the normal regular overview. That's the command line version, for example. However, if you're interested from a developer point of view, you may actually look into libraries that are available and correspond to Git. And there are some available. For example, this one is, hang on. It's a Perl interface to the Git version control system. So basically, the specification of how to, or documentation of the library and how you can access it using Perl. Yeah. So different perspective. As a system developer, that's more interesting for you. As a sysadmin and user, the first section would be the relevant one. Right? Make sense? Bit? So it's something to explore. Just bear that in mind. Sometimes commands appear in multiple sections. So it's quite important to indicate which section you're interested in. But for default user commands, generally it will default to the first section anyway. Cool. And we're probably not going much deeper than that anyway. No, cool. Good. But we'll see. I guess we're giving you an overview here anyway. If there's anything else that comes up later on and we feel, oh, you should have known about this, we'll sneak it in here and there. But this should give you a scaffolding of an idea of what Linux is about and how it works. Again, note that the slides are a bit exhaustive sometimes. I leave them this way because it's easier for you to go over them by yourself and read through and get the story. I'm not necessarily referring to each point here. So basically, it's just an overview of the help and how you effectively use it, right? So if it describes the syntax, for example, you have the command, you have entry options that are listed here in the help, and then a compulsory component, which would be the login in this particular example, right? So if you have a user mod command, we get to that command in a second. You you need to necessarily specify a user you actually want to modify. Command is about modifying users. Cool. Right. Cool. Man command. We went through this one. Some commands you already know include pwd, right? pwd is prints your current location. That's always quite good if you're navigating, you don't know where you are. just press type pwd. We looked at ls. We know that ls has various parameters you can explore, and you guys know cd as well. It's the same in Windows. Only difference here is you need to have a mandatory white space between the command and the actual parameter. In Windows, you don't need to do that. Linux is much more specific, and obviously Linux is case sensitive, something I should have mentioned earlier. Very important. Windows is very agnostic in this respect. Linux is not, and you shouldn't be either. You should be very sensitive to it as well, because you want to be developing cross platforms ideally. So just be case sensitive in your practice. The super user. Okay, a lot of text, but not much message behind it. The essence is, when you work in Linux systems by default, unlike Windows, you work as a normal user. You don't have particularly elevated privileges. You can't make global changes. You can't affect other users. You can't install device drivers. You can't install software. So basically those ideas. Anytime you need to do this, you need to do it as a super user, yeah, or commonly referred to as root. In most instances, or in most modern distributions, or many modern distributions, don't allow you to log in as root anymore, because they want to prevent you from actually working persistently as root, which we tend to do in Windows sometimes. You just, give us administrative permissions or privileges, and we leave it this way until we click on the wrong email. But this won't happen in Linux. It's part of the reason. So also the concept includes the fact that the super user by default is not able to do everything, but the super user has the power or potential to get privileges to do everything, right? So you can constrain the super user from doing something, but the super user will be able to regain those privileges by his functionality. So, cool. So if you run something as sudo, a super user, let's see. Thanks. If you run something as super user, want to run something as super user, and you can't log in, but I'll show you some workaround for that one. You run it as sudo, right? So basically, it's a sudo command. That means for this command, you'll be elevated to super user and run this command. It will ask you for a password. The password is your password, not the super user's password, because you may be given sudo permissions. But the system will inquire with a given timeout, will inquire whether it's actually you sitting behind your command line and ask you to enter your password again. So when you as a normal user, you can install software by having running sudo first, and then the command you actually want to run. Since in life, most of the time we get it wrong. We do something we're not supposed to do. Let's try that out. I'll show you a command that is quite important later on. Apps install mc. And you get something like this, and you're wondering what's happening wrong. The error messages are not explicit. They don't necessarily tell you that you're not super user. What I tried to do right now was to run apt install mc. If you recall from earlier, apt was the package manager in Debian-based systems, therefore also Ubuntu, and apt installs a software package called mc. For the interesting ones, it's called Midnight Commander. It's like a Norton Commander orthodox file manager, but it actually gives us something like permission denied. And those errors are not necessarily super explicit, but it usually means, well, you got your command from.
It asks you, are you root?
Sorry?
It asks you, are you root?
Oh.
In the second line.
It does, yes. But they don't necessarily need to be explicit. So sometimes it's really cryptic, and they're not really helpful in terms of finding it out. But this one is reasonably explicit, yes. So your options are basically to run sudo in advanced sudo install mc. But if you're too lazy to retype that, I say it explicitly, you can use the double exclamation mark. It basically holds the last command you have executed. So this, in this case, will ask you for your password, and if I type it correctly, then it actually does what I want it to do. It installs some stuff, and it happens that the tool is actually already installed. But notice, as if you're not super user, you can't even figure that out. It won't even tell you that you actually have the tool installed already. So sudo is quite essential for many activities when it comes to installing software, affecting other users, or making system-wide changes. Yeah? Cool. All right. So do we need some sort of break? Yep, we probably should have a break for, let's say 10 minutes, until 1:25. 13:25 is possible, and then you can get some hot chocolate and recover from me, and then we'll see how we continue. Perfect. Interrupt the podcast.
Well, then it will be